So is what you're saying, since there obviously was a Big Bang, since we're here, you're more comfortable with placing the morphogenetic causality as something which moves from the past toward the future rather than from the future toward the past, because the hypothesized final end state we have no evidence for?
Well, there are two things. That if the influence from the future in some sense influences creativity, if that in some sense causes new forms to come into being, once they've come into being, I think that they take on a life of their own, and there's this kind of memory aspect. I think memory is so intrinsic a part of our own life, so obviously a part of all life, so undeniably the basis of all our experience, that any view of the universe that doesn't take memory seriously as an influence from the past and tries to substitute in its place an influence from the future is going to be inadequate. And if there's an influence from the future, I don't think it can work in the realm of memory and habit phenomena, which we know very well depend on the past. Rather, it may work in the realms of the as yet, in the realms of the possible, which are the realms into which we're always moving, and they're the realms which, in fact, consciousness inhabits. I mean, consciousness is the realms of the possible, as far as I can see.
Well, I think one way to think about information coming from the future is to imagine that ordinarily this is not allowed, but to make a quantum mechanical metaphor, you can imagine bits of information that tunnel into the past in the way that particles overcome energy transitions by magically appearing on the other side of them without ever having gone over them. And it's possible to imagine that a very small amount of information actually leaks into the past, and that this information becomes the province of seers and shamans and visionary thinkers of all sorts, that creativity is this appetition. You know, there's a word in Gaelic, haraeth, which means simultaneously nostalgia for the past and the future. And it seems to me that kind of nostalgia for the past and the future is what drives great creative spirits, poets, and visionaries. And it has this enchanted, this fey kind of aura about it, because information from the future is necessarily magical. It exists, and yet it cannot exist, because in its existence is implicitly is a paradox.
Well, I think there are two ways that information from the future works. One isn't really so much information from the future as what I'd think of as the primary cause of the whole thing, which is the attraction of the attractor. There's something in the future which draws us, for example, forwards. And what we experience the future as is not as definite information, not even as exactly concrete plans, but more in the experience of hope, and more consciously in the experience of faith. And faith is basically a vision of the future which we believe in and believe is the right one for us and to which we're attracted. So people who have, as we read in thousands of books on how to get on in business, if you have faith that you're going to succeed, you really believe that you're going to be rich, then the chances are you may well be so. Whereas if you don't actually want to be rich, and if you don't have faith in it, and if you don't keep putting out that kind of image, and if you don't have that hope and so on, then the chances are you won't be rich. So there's also the kind of religious faith that drew the Pilgrim Fathers to the United States, and it was the faith from the Judeo-Christian heritage, the promise of the faith in the promised land, the promise of a land in the future or somewhere else which will be flowing with milk and honey, where there will be bounty, prosperity, the land will yield up its riches. The land, of course, of the original promised land wasn't empty. It had inhabitants in it, but they were killed off, and their land was appropriated. And this was the promised land was that, and it's America. And that dream of the promised land which drew everybody here to America, or their ancestors, is this kind of hope, this drawing, this attraction, is what actually we know from our own experiences how this attraction works. It works through faith, through vague mythic hopes, through sense of promises as yet unfulfilled, and so on.
Well, the disturbing thing about that, then, is what you referred to, this utter conviction in the approaching end of the world, which motivates vast numbers of people caught up in this monotheistic myth system. All the major monotheistic religions appoint an end to the world, and for several of them it's soon.
But you see, I think we're in a worse way than you may think, because if we say, all right, let's not bother so much with these monotheistic religions, what other models? Since I think that if morphic resonance works, then it means that our collective unconscious, and particularly our cultural unconscious, contains elements which they're so deep down, they influence us much more deeply than we know. And the Anglo-Saxon race, the English language, its cultural roots are in Germany. And the Germanic gods, the whole Germanic mythology is that the whole age will end in a twilight of the gods. And one of the problems that Hitler had in reviving the German gods is that entire theology of those gods, the entire pagan system of the Germanic gods, is one that comes to an appalling end in the twilight of the gods. Even the gods die out in this twilight of the world, when there's a destruction of all things, Ragnarok. So even if we look to pagan mythic sources, as well as the Judaic ones, and even if we look to the Hindu mythic sources, the idea of the Kali Yuga at the end of every age, where there's this densification of time, and finally the entire universe is dissolved. And then at Brahma, it's the inhaling of the breath of Brahma, and then a new universe is created or breathed out. It seems to me that a great many of these have this view that would lock into the idea of an end to time.
Yes, well, or an end to history.
Or an end to history.
It's occurred to me recently in thinking about this, my own model of time comes to an abrupt end. For all of its prophecies to work, there has to be an end date assigned, and it only works when the end date is assigned very close to the end of the Mayan calendar, which is 24 years in the future. So I've spent a great deal of time trying to imagine how the world could end in 24 years. How is such a thing possible without just, God Almighty descending in a chariot of flame? But how could it happen without that? Could there be a plausible scenario created that would have our world utterly end in 24 years in a happy way? And it occurs to me that the way in which this is to be accomplished is staring us in the face. It is simply this, that shortly after the first few years of the next century, a technology will begin to be developed, the purpose of which will be to transmit a message forward into time. And unbeknownst to the technocrats who will create this massive governmental project to communicate with the future, will be certain paradoxes which are built into the effort to do this. One of the things that will be discovered is if you invent a time communicator that can send a message into time, into the future, then anyone in the future can send a message back to you, but no message can go further back into the past than the moment of the invention of the first time machine. Do you follow? So suddenly in human history, an absolute membrane for information is established Before time communicator, all causality moves from the past to the future. After time communicator, causality moves both directions. And consequently, more advanced states thousands, millions, hundreds of millions of years in the future will diffuse through the entire temporal medium like heat through a gas. And at that point, what you will suddenly find is the moment the switch is thrown on the first time communicator, the future end state of evolution on this planet will appear 1 microsecond later, because the entirety of the future will be forced to happen all at once. I'm not sure you're with me. What?
That's pretty good. Keep going.
So basically it's simply a technological innovation which would be like a whistle for calling Almighty God into the historical process. The first person to invent a device which communicates with the future will discover that all of the future is suddenly communicating with them. And this will be experienced as a very radical sort of transition in the way we maintain our homes and businesses. Well, I don't know. I think we've run past intermission time. Maybe we should have an intermission, and then all these people who are burning to ask questions should come back. How do you feel about that? Who whines behind the lights?
Just a response.
Just a couple of questions.
I don't care. Fine. You.
If that were true, we'd already be affected by that, though, wouldn't we? Well, because when that switch got thrown and the future kind of falls back onto that moment, the past is going to pile up behind it with momentum.
Well, but we haven't reached that moment when the switch is thrown.
Somebody has.
But the future cannot go any further into the past than that moment.
Absolutely, but the past is still going to pile up upon that point because the past is in a causative mode, right? First one thing, then another, and another.
Well, don't you think that's what's making the world so crazy?
Maybe not.
It's that we are running smack into another dimension. And that's what's creating the shock wave of cultural effects that we call the 20th century, but which, once we get through all this, it will be known as the bow shock of transition to the millennial eschaton, or whatever it was.
I've been storing up questions on that, but the most recent one is about the nature of time and whether in fact it is linear and, I had a talk with a couple of people, Mark Miller and Roger Gregory, who run Project Xanadu for Universal, the World Library, and they clued me into one of these great cosmic secrets. They told me about a month ago that time is in fact asymptotic, and that we are approaching the asymptote, and at that moment, this point is known as the naked singularity. And he said, we're entering this asymptotic curve now, and this is when the quote-unquote the weirdness is about to begin. It's where synchronicity begins piling up on synchronicity. And I wonder if this fits in with any work of yours.
Well, I think that this asymptotic thing that you're talking about, how you perceive it depends on where you stand in time. There is a certain point of view where only a few moments after the Big Bang, the asymptotic weirdness began to set in. It was interesting, a few weeks ago I was visited in Hawaii by none other than Carl Sagan. And he had a number of things on his mind, but one of the things that he was at great pains to point out to me was I said something about this asymptotic approach to the end of history. And he said, well, my dear boy, you just have it all wrong. The speed of information transfer reached the speed of light with the invention of radio. It's been absolutely flat ever since. The largest thermonuclear blast ever detonated was in 1958. There hasn't been a bigger one for 30 years. The fastest human object ever built was launched in 1967. There hasn't been a faster one since. So this nonsense about ever increasing this, that, and the other just doesn't hold water.
But you're dealing with the cybernetic.
Well, what is increasing asymptotically is density of connectedness. And obviously, at a certain point, you reach maximum density of connectedness in the present. The only way you can then continue to densify connection is if the connections begin to move outward in time, into the future and into the past. And you undergo this transition from particulate Cartesian Newtonian existence to this wave mechanical, shamanic, both present in the past, present in the future, present in the present kind of existence. This is what I meant about the social implications of integrating Rupert's paradigm. It is permission to feel this new way and to know that it is a more correct mirroring of the greater cosmos than the model that had us as the citizen, the ego, the individual, all of that sort of thing.
Well, we're on the threshold of major changes in our information universe, based on, hypertext and so forth, which would allow us to go quantum, that would be the next.
Well, see, I think it's something much more profound than that. Let's take my example about the time communicator for a moment, and let's tell a little science fiction story to make it more understandable what I'm talking about. Let's pretend it's not a time communicator, it's a real time machine. And we're going to send somebody into the far-flung reaches of the future. And we've never done this before. And so we load them into the jeweled device that we've built in our laboratory, and we pass out the champagne, and we have a brief countdown. And then we throw the switch, and our lab chief sails off into the future. Well, now what do the rest of us sitting there see? What happens at that moment? Well, at first I thought what would happen is suddenly all over the world time travelers would begin arriving from the far-flung reaches of the future, having come to witness the first voyage into time. Obviously a great thing to see if you're a time traveler. It's like if you had a Cessna airplane that you could fly to Kitty Hawk in 1906, wouldn't you fly there and see? But it kept nagging at my mind that there was some paradox in this, or something was wrong with this idea. And then I said, aha, I see. What it is that it's the kill your own grandfather problem. If time travelers could travel backward into the past, even as far as only the invention of the first time machine, one of them might conceive, one from many centuries in the future, might travel back and kill their grandfather and initiate that good old paradox of how could you kill your grandfather? Because you killed your grandfather, you didn't exist, so how could you exist to kill your grandfather? That sort of thing. But then I realized, no, in the same way that the most advanced cultures on the sphere of the planet dominate and overwhelm less advanced cultures, the most advanced future states would dominate and overwhelm the entire temporal continuum clear back to the moment of the invention of the first time machine. So what you would really see when you threw the switch on the first time machine would be the simultaneous arrival of the ultimate state of human evolution, whatever that is, something beyond our conceiving. So it's in very practical terms, it would fulfill this apocalyptic dream of monotheism. It's conceivable that if we could invent a device which would transmit information or objects forward into time, that the moment that device were invented, we could call upon the resources of all future human history to bail us out of this mess that we're in. It may be the only way to save the planet. An immediate time wars commitment to spare no effort to send information forward into the future looking for help. I'm not serious, of course, but I am peculiar. On that note, why don't we take an intermission and then come back? Oh, I don't know, 10 minutes, something.
That's a lot of questions.
Oh, well. I'll take one bit first. I mean, there's a lot of separate questions. The punctuated evolution thing, the idea that evolution moves by fits and starts, which was denied by neo-Darwinists and by Darwin himself in favor of the idea of a slow, gradual, steady progression, moving at a more or less uniform rate. Darwin was a great disciple of Lyell's and the principle in geology of uniformitarianism, the idea that things go on at uniform rates. And this particular school of geology was opposed to the theory of catastrophism, the idea that there are catastrophic events on the earth, like the flood, the biblical flood, and that the development has been discontinuous. There's been breaks and fits and starts and periods of more or less stability and then big changes. That catastrophist theory, which was a popular theory at the beginning of the 19th century, was rejected by Darwin as it was rejected by Lyell, because as soon as you allowed catastrophes, all the Christians agreed with this and said, yes, the Bible tells us that. We know from our whole cultural history that there are catastrophes, and this is saying the same kind of thing. They wanted to be saying something totally different that wouldn't fit into any kind of biblical view whatsoever. The idea of a totally progressive, linear process of change. Anyway, the fossil record never supported that, and punctuated equilibrium seems to be what happens. And it suggests that evolution moves by fits and starts. And what started as an appalling heresy, it's been a recurrent heresy ever since Darwin first put forward his book. People have objected to it on the grounds that evolution may well move by fits and starts. Even T.H. Huxley disagreed with Darwin on this one. Anyway, if evolution moves by fits and starts rather than uniformly, then it looks as if there's not a uniform rate of novelty formation in the universe. And of course that's just what Terence tells us.
That's right. One way of thinking about the novelty wave on the largest level is that it is a picture of the ebb and flow of mutation in the history of life on the planet. In other words, the idea that mutation is random is based on the untested and cheerful assumption that radiation is arriving at the rate is arriving on the Earth at an even rate. But there's no reason why it should be. If the rate of radiation arriving on the Earth were fluctuating for any reason, you would expect to see a concomitant fluctuation in the fossil record. And there are many other reasons. A catastrophism, the idea that there have been extremely violent episodes in the Earth's history, huge volcanic outgassings, cometary and asteroidal impacts, and this sort of thing, is now pretty widely pretty widely accepted. And in fact, the extinction of the dinosaurs is put down to an asteroidal impact. But go on, it would be interesting to hear you deal with the salts that tire.
Yes, I'm fascinated by these salts that get tired. I don't know, I mean, I'd be interested to get from you later a reference to the literature so I can look it up, because that sounds really interesting. Eutectic salts going backwards and forwards and getting tired. I mean, the only thing that I'd think offhand in response to that is that I've been thinking quite a lot recently about exactly that kind of phenomenon, melting points, and asking the question of myself and of chemists that whether compounds that are fairly newly synthesized, when they're crystallized, have a particular melting point, and that as time goes on the melting point might change, because the habit which holds the crystal in its form might become stronger and it might be more resistant to thermal disruption, so the melting point might go up. It turns out that in the chemical literature, far from being fixed, melting points fluctuate. In the published literature, I've found differences of up to 12 degrees over 20 years. And there do seem to be extraordinary fluctuations, and most organic chemists agree that the strange changes occur, that they don't seem half as constant as they're cracked up to be.
Maybe we can keep the ice caps in place then.
Well, that might be
changing the melting point.
The eutectic mixture, you see, one of the things I've been thinking about is that when a substance melts, you've both got a formative field of the crystal, but the liquid phase of the substance also has a morphic field. Liquids have characteristic properties. They're not totally chaotic and formless. They have, and if it's a new substance that's never been melted before, it won't have had a sort of morphic field for its liquid phase. By repeated cooling, and I was trying to think of experiments involving cycling a substance through cycles of melting and cooling, because there would be a way in which the number of transitions and also the endurance of the liquid versus the solid phase would tend to stabilize the morphic fields of these two phases. And in a sense, around the melting point, it would be as if there were two competing fields. And if one were the stronger, it might tend to raise or lower the melting point. So I've been thinking about this sort of thing, so I'm fascinated to hear about these eutectic crystals, and I'd love to read out the literature. I'm adopting a very traditional scientific position in one way by assuming that by putting forward the hypothesis in its most general possible form. If I said it sometimes works and it sometimes doesn't, then it would be very difficult to test, because and it would actually be irrefutable. That's a vice and not a virtue in a scientific theory. And so I'm more inclined to think of it trying to think of it working everywhere. Now, there are many systems like the behavior of hydrogen atoms, the crystallization of sodium chloride, and all sorts of phenomena that physics has studied in great detail, which have happened billions of times, and as far as we know, for billions of years, even before this planet formed. So there are certain kinds of phenomena in nature which have happened so many times before, they're so deeply habitual, that they behave as if they're governed by eternal laws. The habits are so deeply entrenched. And I think many of the phenomena that scientists have studied, particularly in the physical sciences, are of that kind. And therefore they do look as if they're governed by eternal laws. Where the difference shows up is when you look at any new phenomenon, because then you can see the habits building up. With old established habits, they might look as if they're not really habits at all, but following eternal laws. So I would say that I would prefer to think of the theory applying everywhere, and I would account for the apparent non-changing of many physical habits in terms of their extreme antiquity and the fact they're so deeply embedded in grooves of habit they don't change.
Some things you simply won't be able to test.
Well, you can test the theory in any area where you can do something new. New forms, new crystals, new molecules, new patterns of protein folding, new ideas, new ways of learning. There seem to be plenty of areas it can be tested in.
Is there anything that would hard to refute your theory, or what do you consider its status of? Is it just a good idea with a few experiments? Or?
It's a hypothesis, which what a hypothesis is a guess about the way things may be. And what I've done is contrasted this guess in a variety of areas, the realms of memory, crystallography, morphogenesis, instinct, behavior, transmission of learning, behavior and evolution of social groups. So I looked at the predictions of this way of looking at things compared with the standard way of looking at things. And in every area one finds that there's a whole range of shadowy phenomena where the evidence for the conventional position is very weak indeed. And one sees that that's actually a guess too, which is in most essential areas unproved even now. So one's got one guess versus a much more common and habitual guess. And there are other guesses on the market too.
Is there anything that would falsify the morphogenetic field in your mind?
Well, a failure of experiments to show morphic resonance would falsify it, except that falsifying scientific theories is never... People often go on as if they say, Popper says the ideal is to falsify theories. I don't know a single example of science proceeding in that manner. Most scientists are trying to prove theories. And they may try and falsify theories of their rivals, which is the way it usually happens. But and it's a kind of dialectic then. Science becomes a dialectic between rivalrous rivals. And science is full of ego rivalries. Well, most people think that this is a terrible vice, but actually it's one of the motors of competitive science as we know it. If somebody puts forward a theory and someone has a rival theory, and then the way the contest is decided is by experiment. The rules of the scientific game. Experiments are usually designed to test between rival hypotheses, rather than testing a single one in isolation. And I'm putting forward a variety of tests which test between the idea that nature has this habitual tendency as against the conventional idea, which is always that nature is governed by immutable, changeless, eternal laws. And some tests may be inconclusive. Some tests may, I think, favor the idea of morphic resonance. If all the tests that are done fail it, if it fails, if it looks as if things are governed by eternal, changeless laws, that there's no evidence for any incremental change in time in any area, that everything goes on as if it were governed entirely by laws that were already there to start with, I'd find that rather surprising. But failure of these experiments would actually support that view, and the conventional view would then, for the first time, actually have empirical evidence in its favor. Because this would be the first time it's ever been challenged. And if those challenges fail, it would strengthen it. So these tests, I think, are in everybody's interest. But if they support the idea of morphic resonance, then indeed it would show that that is not a perfect model. It's the idea of a memory in nature, morphic resonance, however crude the theory is in its present preliminary form, it would be a better theory and a theory more worth developing. And the question is the field connection in quantum non-locality in Bell's theorem and the Einstein-Rosen-Podolsky paradox, that kind of quantum non-locality related to morphic resonance? Are they two aspects of the same phenomenon? That's the really interesting question in relation to existing physics. And nobody knows the answer. I don't know how morphic resonance as conceived would fit with quantum non-locality, which, although it does in fact involve a past, because both systems originate from a past, and it's to do with a system with a past, which is, I would say, the very existence of these particles is a kind of resonance from their own past. And I would say that there is a kind of morphic resonance link, and probably that's what it might be. But I can't fit that into the formalism of quantum theory, because I don't know it. I'm not a quantum theorist, and to work with those equations with any degree of subtlety would require a deep understanding of the subject. On the other hand, J.S. Bell, the inventor of Bell's theorem, has been in correspondence with me. He's read both my books and has sent me his latest book. So we've been in a correspondence about the possible connection between morphic resonance and his own theory. He's perfectly intrigued by morphic resonance and morphogenetic fields. And he thinks they may be connected with his own theory, but he can't see how, because there's nothing in the conventional physics which is yet proved, because it's so based on eternal equations. The idea of Schrödinger's equation is a kind of eternal Platonic form that governs all quantum processes from the beginning of the universe to the end in exactly the same way. That's the kind of inherited formalism of quantum mechanics, and that kind of mathematics, which postulates eternal Platonic type forms, is not going to be adequate for modeling an evolutionary universe. And so it's not clear how the bridge can be made, or even whether that connection, but I think there must be some kind of connection. There can't be lots of totally unconnected types of non-locality in the universe.
Rupert, why not replace the Platonic models with fractal models and then say that time itself is the morphogenetic field? That it is some kind of fractal topological manifold and so the repetition or the connection to past states is really accomplished through resonance within the fractal, and then we have a model for resonance because it's familiar to us from other domains of nature.
Well, I don't see quite how there's a sense in which the fractal is a new mathematical model that gives us the same idea that the ancient idea of the microcosm mirroring the macrocosm. The idea of different levels.
Well, but not only different levels, but different points on the same level, in the same way that the past occupies a relationship to the future of formative anticipation, so in a fractal do early portions of it anticipate later forms. So it is like a prediction, a self-fulfilling prediction is what a fractal is. It predicts by virtue of its past states. They define what its future states will be, exactly in the same way that I imagine the morphogenetic field defines what future states will be. The fractals that have been talked about to date have been used to describe spatial phenomena, coastlines, molecular arrangements, distribution of flowers in a meadow, this sort of thing. But if instead you thought of fractals as descriptors for the temporal dimension and replace the notion of a flat or slightly curved manifold with an actual fractal surface over which events were flowing and flowing over patterns which repeated themselves at many, many levels in resonance with previous similar patterns, then you would begin to have a mathematical picture of how the morphogenetic field would work, and you would also have found a phenomenon in nature upon which to hang it by saying time is obviously it. It's just that we are so ingrained by Newtonianism to accept time as an abstraction, as something not having equal status with the other three dimensions, that we've overlooked this fact. And yet, obviously, that is the carrier wave. That's why you would speak of the presence of the past. What then can it be but time, past time in the present?
Well, it is past time in the present. But the fractal wave, you see, why I don't like the fractal model taken to any great extreme is because any kind of mathematical modeling, given the whole nature of mathematics as it's practiced, fractal mathematics is conventional paradigm in the sense that you create an equation and you generate this form. The equation itself is not subject, the governing equation is not subject to evolution. It's generating the same form, and it would go on generating the same form right into the future. In other words, it would be a kind of determinism based on a kind of Platonic or Pythagorean ideal form, the fractal equation, which generates the fractal. And I don't understand evolution as happening like that. I don't think it's as deterministic.
Well, you're right, that as they are presently understood, it would generate, however complicated, ultimately a determinism. But I wonder if we're just not mathematically sophisticated enough to inculcate into the fractal equations sufficient randomness within the fractal constraints to begin to get the kind of complexity that we meet in the real world. That would seem to be what is lacking, is a random factor that causes the fractal equation to skew toward production of ferns, and then suddenly to switch over to feathers, and then to river systems, and then to industrial economies or something like that. But if it can do all these things, it can model all these things, but as you say, in a deterministic way. But maybe we don't know enough about them yet, and that there may be higher dimensional or higher order fractals with a degree of self-determinacy or autopoiesis built into them. I think this must be so because I think the world we're living in must be such a world, and that we are these fractals. We are essentially three-dimensional expressions of DNA, and all the DNA is the same, and yet each one of us is different, and yet 10 of us are like any other 10, and yet different. And we, as human beings, have this same quality, and so do our cities and our nation states and the continents we inhabit and the religious systems that we're inside of. So it seems to me the fractal model may be the one which holds out the greatest hope for a formalizing of the morphogenetic field. All other fields are fractals. The electromagnetic field, the radio wave, all of these things are found to have this quality. And in fact, the development of this kind of mathematics initially was in an effort to describe the field phenomenon, Fourier transforms and that sort of thing. So then why not this one? And then that vastly narrows down the mathematical domain in which you have to search for a formal description of the morphogenetic field. It would also yield a perfect theory of history, because that would be part of the morphogenetic field.
Well, I suppose that one of the problems I have is that I'm not so fascinated with mathematics. I mean, I don't think that mathematics, most mathematicians think that the maths is more real than the thing it models, that the equations of the universe are more real somehow than the universe. They were there before it, after all. They were its source. They were prior to it, both logically and temporally. They're the more real thing. This is the Platonic tradition.
Platonism.
And this is alive and well. I mean, its latest, greatest exponent in the bestseller lists of the last few months is Stephen Hawking, who, as a perfect exponent really of that Platonic view of the eternal intellect, the eternal mathematical mind, which somehow is over and above the universe. The mathematical mind of God, in some sense, is there before and prior to matter or bodies. And as one of our British journals put it, that Stephen Hawking is the closest thing we have to a disembodied mind. And it's a perfect, you see, in a sense there's a perfect, I think the reason for his mythic quality, because he is a mythic figure, of mythic power, is because of that. And the vision is totally consistent with it. And so I don't really, all mathematics tends to have that quality. And I would think of the fields not as something which to grasp we have to model mathematically, but as something which I'd think of them as much more like living things, and our models would be much more and more appropriately based on an intuitive sense, a living sense of things that we actually learn from experience as living things ourselves. So the models would be much more communicated by seeing how they correspond to our actual subjective experiences, the kind of things that we experience.
So through ordinary language.
Through ordinary language, through the realms of the imagination, through our understanding of memory, through the mind, through the power of hopes, fears, desires, fantasies, through the experience of our consciousness as the realm of the possible. And so these are much the best models. And mathematics is a tiny fraction of a formalized modeling of the possible, which is constrained by very particular rules and is entirely, so far in the whole history of the subject, under the aegis of the Platonic spirit. And I just think that to try and pin it all to that just seems a limitation that one doesn't need at this stage. I mean, it may be helpful, it may be interesting.
My God, I see why they're alarmed now. Yes, well, I'm sure you're quite right. So what you're really calling for is the rebirth of poetry.
Well, and all kinds of lived experience through which we directly relate to the world. Because a science which helps us directly to experience nature, and actually when we walk in the wood, understand it more deeply and more profoundly than we do now. Something that tells us something we don't know about the quality of woods, trees, the nature of the bird song we hear, how they communicate. I mean, I think they're just call signs, their songs, and the actual message is, as it were, telepathic once they've tuned in through the right calls. This kind of world we might come to live in and actually experience. And the mathematical models just wouldn't seem, I don't think, terribly interesting or important.
Well, so this is the connection to the psychedelic experience, the felt realm of immediate perception, that somehow with the psychedelics we're coming into the full spectrum of our experiential birthright. And you're saying that this theory, correctly assimilated, brings us also into a full appreciation of the felt spectrum of experience that is our birthright.
It makes us realize that we're living in a magical world in which there are unseen connections, that the power of thought and imagination and dream actually has a reality. And our ancestors lived in such a world. And the whole medieval and animistic world and the worlds before that. And most people in the whole of the world have lived in such a world in which these things are possible. It's only since the 17th century that our civilization has stripped the world of its magic. And it's stripped the world of its magic by turning it into a machine. And if it becomes a living organism again, alive once again, as I think it's becoming, then it's a living thing, and we have to relate to it as living things. And the disembodied mind approach of totally abstract mathematics, seeing the universe as if from without, the whole point of the mechanistic picture is that you withdraw yourself from the world. You see the world as a spinning ball, as we've now finally, through the space mission, come to see the world. It's a total confirmation of the initial leap of the mechanism of Copernicus. It's a proof of the Copernican theory in the most dramatic form, because it was to step off the Earth, which everyone else had taken the Earth as the center from which to model things, because it's the center from which we experience them, and it's true to our experience. Saying that's not the center at all, and Kepler in 1609 wrote this early work of science fiction, The Dream, when he imagined himself being in a transport, a visionary state, transported to the moon. On the moon encountering strange creatures that lived underground and crawled out from under rocks, and looking back at the Earth and seeing the Earth spinning on its axis, just as astronauts and our cameras see it from the moon. And using this in his book, The Somnium, to persuade people by this thought experiment to see that the Earth could be moving even though they themselves experienced the rest of the heavens to be moving. And this is the thought experiment that takes our minds off the Earth and puts them out in space, and then through Newtonian space takes them outside the entire universe until they occupy the same vantage point as the imagined God of a mechanistic world machine, somehow external to the mechanism. And this is the world in which Laplace and his followers thought that their minds were actually dwelling through experiencing these eternal mathematical truths, learning them in physics textbooks. And there they were, the eternal truths of the universe as known by God, if such a God existed. And so the human mind was totally abstracted from the whole universe, leaving the body and the feelings behind in some other kind of realm, the realm of everyday life, poetry, imagination, religion, etc. But the intellectual understanding of the whole universe, which was finally applied to the whole of this earth, to the whole of life, to the whole of the human body, and finally to the whole of the human brain, purporting to explain everything in terms of this abstracted intellectual vision rooted in eternity. as the mind of the scientist somehow outside the universe observing it. This has been collapsing. I mean, the observer in quantum theory, the unworkability of that view, and now the collapse of any justification for eternal laws. And so I think that we don't really have to stay in that. We have to change our whole way of experiencing it, yes.
And it is an archaic return. It is a brief intellectual detour since the 17th century, as you point out.
Terence is interested in the time flows, and I'm interested in the habits. But I think they're complementary, because you're never going to understand the quality of time flow if you haven't already understood the power and nature of habit. Because there's no doubt whatever that a great deal of the time flow that's happening, in spite of all the fluctuations, involves the persistence of a vast number of habits, which is why we're all here tonight. If these habits, the major ones by which we live from day to day, our bodies work, our language works, our social conventions work, and so on, if these habits were severely disrupted, it would be virtually impossible even to sit here and talk about it. We're here because there's vast stability of habit. And so I think that one has to understand the habits as well as they're two sides of the same coin in a sense. The time flow and its quality are what affects, or it's the other side of the coin of habit, and understanding them goes together, I think. But I would see the primary task, as I see it, for me at any rate, is to try and establish the nature of these habits. Once we understand the nature of habits better, I think it would be easier to set up, if one wanted to study the nature of time flow around, one would, I suppose, look for correlated events around the world, seeing whether certain patterns of events tended to happen around the world. What Jung would call synchronicities, which he thought of as manifesting some kind of underlying pattern in the flow of time. And so the study of synchronicities already exists, of course. Jung initiated it, or even before him, Camera and others. So that's one way of looking at time flow, because synchronicities suggest there's something behind the scenes of what appear to be new events in different places. So no, these are complementary approaches. It's not one or the other. And I think both the study of synchronicities and the quality of time might help to explain a lot of anomalies in scientific experiments. Very few scientific experiments are repeatable, in fact. And they're repeatable only approximately. Now, I've spent years teaching practical classes in Cambridge and other universities, Harvard, teaching practical classes to undergraduates in biochemistry is an enlightening experience, because they're only given experiments to do which are textbook experiments everybody already knows work. I mean, you wouldn't give students something that's not going to work. So you give them the most certain, established, and repetitive and repeatable of all the systems you can think of. You don't want them right up at the research frontiers where results fluctuate wildly and no one knows really what's going on until it's sort of stabilized, been published, and become a kind of habit of thought and expectation. You give them things that are already believed by everyone to work. And the results you get are astounding. They're all over the place. I mean, even competent undergraduates, the results are extremely variable. For any biological experiment I've ever had in hundreds of ones I've conducted in lab classes, they're given the same apparatus, the same pipettes, the same solutions, the same, lab technicians put these things out by the dozen in first year and second year undergraduate practical laboratories. And the results are all over the place. Well, even in third year undergraduate things, in graduate studies, the results keep coming out all over the place. And you explain away the ones that don't work. Either they didn't know the technique, they put the wrong solution in, they must have done it this, you must have done that, you must have done the other. And you can find 100 ways to explain why that actually happens. The only actual examples we have where people try to repeat experiments on a mass scale turn out to be highly unrepeatable. And most scientists don't spend their time repeating standard experiments and measuring whether they fluctuate or not. They're always getting on to the next thing. And so this ideal has never been tested. And I think if it is tested, we'd find perhaps synchronized fluctuations in the way experiments work in labs around the world. People have lab notebooks kept separately. The way of presenting the experiments, you never mention the date you did it. It's assumed that time flows uniformly. We say figure 1 shows the effect of magnesium ions on the activity of phosphofructokinase, and you have sort of enzyme activity, magnesium ion concentration. There's this graph. It's treated as if it's an eternal truth, and yet any biochemical experiment you do, they're always different. I've done hundreds in my time. You publish one of them that gives sort of plausibly fits the data, and you say representative results are shown in figure 1. And no two experiments give exactly the same results in any real interesting scientific system, such as those looked at by biochemists and so on. And so I think actually there's vast amounts of data. If scientists dated their results, for example, this would be an elementary move towards recognizing the quality of time. And if one found that sort of all particular kinds of results were dated there, and if scientists all around the world found that, say, on the 12th of September, experiments weren't working very well, but they all tended to work on the 15th, this would be very interesting information. Everyone agrees that sunspots, for example, the 11-year cycle affects climatic patterns and growth rings in trees. You can measure it way back. And this is standard science now. I mean, and cosmic ray fluctuations, every year the Earth passes through meteorite clouds. There are all sorts of things that are known to lead, and cosmic rays affect mutation rates, and they're different. And if you do experiments where people have tried to do, some of the Rudolf Steiner people did experiments where they crystallized standard solutions, they crystallized them on different days, the same conditions, and yet the patterns, the dendritic patterns of crystal growth differ from day to day, indicating a kind of quality of time. Now, no normal science would do that, you see, because it's assumed that any day is as good as any other. So there in lab notebooks, if you went to the data's all there. There's tens of thousands, hundreds of thousands of lab notebooks in the world today. And scientists do date their experiments in their notebooks. You keep a daily register of experiments, all dated. Just an examination of lab notebooks would be quite revealing, and it wouldn't even involve new experiments. But as soon as they write up the paper, it's taken out of its temporal context and put into this kind of seemingly timeless context of eternal truth.
Well, this is because science cannot operate without this notion of the restoration of initial conditions. And yet this is a highly unexamined notion. And as all these anecdotal incidents indicate, there is no restoration of initial conditions. All of science is being practiced on an unexamined and apparently false assumption. So a more honest definition of what science is science is the art of studying those phenomena so crude that they can have an apparent restoration of initial conditions. But that leaves out all investment schemes, love affairs, dynastic families, military campaigns, and what have you. None of those can have their initial conditions restored, and those are the things that are really important to us. So it then is correctly seen to be a very limited way of doing intellectual business, having a very narrow spectrum of applications. One way I think of thinking about the difference between ordinary science and what Rupert is trying to do is to think of science as that enterprise of human thought which attempts to state what is possible. What is possible. But out of the very large class of the possible, certain things are going to have to be selected to actually happen, to undergo what Whitehead calls the formality of actually occurring. And an idea like Rupert's is a way of saying, well, here it's the past. The past is the factor which selects against the class of the possible to narrow it into this much narrower class, the class of those things which have actually occurred. Science never talks about how the class of the possible is narrowed into the class of the actually occurring. And yet this is obviously a big question. We don't want to know what's possible. We want to know what's going to happen. We don't want to know what might have happened. We want to know what happened. And so new ways of thinking about causality, new ways of thinking about time, new ways of thinking about the way influence of form is mitigated into the world of three-dimensional space. Does it come from the past? Does it come from some kind of Platonic never-never land that is a hyperdimension that surrounds apparent space and time? Does it come from the future? Is it like a dynamic attractor? Is it a huge flickering shadow across a lower dimensional landscape that is somehow gathered into itself? These are the kinds of questions that have to be asked to create a new model of time that is empowering of the felt presence of immediate experience. That is the new ground zero of any kind of humane science. The felt presence of the immediate experience of the individual has to be the primary datum of a new science. Otherwise, it isn't going to be a new science. It's just going to be a retread on the old science. Well, it's well after 11 o'clock. Maybe we should pack it in. Thank you very much.